Good afternoon, ladies and gentlemen. Welcome to TechGeek Webinars, our endeavor to empower techies. TechGeek.com has launched webinar series on Advanced Java today, and today's session is the first in the series, and topic for today is effective use of collection framework. We are delighted to have Mr. Bhushan Rakhecha with us today to speak about collection framework and its uses. Bhushan is an experienced technical consultant with nearly 9 plus years of IT experience in developing and training with a specific expertise using Java J2EE technologies. He is a Sun certified Java professional and IBM certified advanced application developer. Gentlemen, this presentation will continue for next 45 minutes and we will take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Bhushan.
Hello everyone. Today we are going to see about some effective use of Java collection, how we should use it, and what are the different type of collections we are having, which should we use when, and is there any performance related issues, and all those things. A prerequisite which is considered for this webinar is that the participants are aware of collection framework and the different classes. Though it is not a prerequisite, but still I will go with the existing classes and the new one added in Java 5, 6, 7 in bit, and then we'll talk about different best practices and what should not be done and what should we do. Okay. So we'll just start with a very basic thing, which is a collection, just as a formal starting. A collection is something which is a bunch of objects stored in a structured manner, so that we can find a specific object from that structure, so that we can replace any object from the structure, so that we can work on these objects which are stored in that. Java has given various structured or standard collection classes which we are using in day-to-day life, and it started with the Java's first edition, Java 1.0, and then gradually they added as a collection framework in Java 1.2, and then in 1.4 they added some more, and then 1.5 they changed the look of collection framework drastically by implementing giving generics, and then 1.6, and now 1.7 is also in market. So let's talk about the collections in Java. So collection in Java is mainly known as a Java collection framework, which is also known as a JCF. It is a library of classes which we are using for storing, retrieving, and working with the objects, like putting the objects in a different structure and all those things. In Java collection framework, we are aware of there are mainly three types of collections we are having. One is a map, which stores key value pair, list which stores ordered way, like it can give you the in objects in the way you have inserted it, and the set which is like the unique set of objects. The first thing which I'm going to talk about, we'll just add it in Java from so the classes which was given in Java in start edition, which is now known as legacy classes, out of which we might have used like vector, hash table, Vector is an implementation like a growable array which grows on whenever you are adding the objects to that, and we can get the objects from vector, we can update it, we can iterate over it and all those things. Another type of collection which was given in Java 1.0 is hash table, which stores a key value pairs. It is a map kind of a thing which maps your key to value. Any non-null objects can be used as a key and or as a value. So hash table doesn't allow you to store null values as a key and value. You cannot get a value directly from a hash table. For that, a key, so that hash table will retrieve the value for that. Any collection which starts with the word hash is what implements hashing algorithms to store your elements in the collection. Then enumeration was also there to enumerate your collection, or we can say that iterate over a collection. So enumeration provides a way where you can go to the you can visit each and every element of your collection one by one. So it has like a next element method which returns the successive element, and it goes on. There are some more concrete implementation of vector and hash table was there was implementation of or extension of hash table was a properties. So properties class and hash table, there was a little bit difference is what properties class was supported, like it can be get loaded from the file system or so, and it will have the key and value in the form of a string only. Whereas the stack is what is the extension of a vector, which was talking about last in first out mechanism. So you can insert the object, and then when you can getting the object, you will get the last inserted object from the vector. Then Sun Microsystem has introduced a complete framework in Java 1.2. We all are aware of that, and we are using that, where like a collection is an interface which is the higher interface and which is extended by set and list. And another interface there is which is a map. Map is, though it's in a collection framework, but it is not having any direct relationship with the collection interface. Then there are again two more interfaces provided in a collection framework, which is a sorted set and sorted map. Sorted set is just like a set, which is a group of elements with no duplicates. Again over here, any collection is not having intellect to identify that this object is a duplicate or not. It completely depends on the equals method of the object which you are inserting in the collection. So it just calls a equals method of your object which you are trying to insert or add to the collection with the having with all other objects. So if the equals method you have overridden, then only you can find that it is not allowing you to put the similar content object in the collection. Otherwise, the equals method which is given by object class, it just checks for the references. You won't be able to see that it is not allowing you to put duplicates. It will allow you to put duplicates if the reference is different, but though the objects are equal with the content. Sorted set is what set which expects the elements are kept in sorted order. It doesn't expect that you should enter the elements or you should add the elements in sorted order, but as you are adding an element to the sorted set, whenever you will get it or whenever you iterate over a sorted set, then you will be getting all in each and every element in the sorted manner. So the default way is what an ascending manner. And similar is for a map where the keys are kept in a sorted order. Then we have a certain implementation of these interfaces. Array list is what a list which is implemented as a backed by array. Linked list, which is a list implemented, which is a backed by the linked list kind of a structured, hash set, which is a set implementation with the hashing algorithm, hash table, tree set, which is sorted set implemented as a tree and which gives you the sorted way. Hash map is again a basic implementation of a map, and which has the base structure is a hash table. Tree map is the sorted map, and there was also one added was weak hash map, hash table based map implementation with the weak keys. This is what like we might not have been used most of the time, so I will just give a brief introduction on a weak hash map. Weak hash map just says like if you lose a reference to the key which is entered in hash map, then that key and value of it is eligible for getting garbage collected. It is not the case for the other like tree map or hash map, but in a weak hash map, it doesn't contain the references, it doesn't contain the entry if it is not referred from the outside, or we can say if it is not in the current thread scope. So it will directly get the garbage collected and removed from the collection. They have given some more classes and interfaces as well. When you are talking about like putting the objects in a set, where we said like a set contains only unique elements, or we can say no duplicates allowed. So in that case, set talks about that how it will identify the duplicates element. So it needs to compare two elements to identify that. In a sorted set, when we are talking about it has to be sorted ascending or descending, then who is going to give that the comparison logic for the two instances of a class, so that we can say like this instance will come before to the another instance. So that logic has to be given by the object itself, and for that object class of which object we are going to insert in the sorted set kind of a or tree set kind of a collection, that class should either implement a comparable interface which comes with the compare to method and which returns int, where a negative, positive and zero value can be returned. So the negative value says that the object which is getting compared with another object is smaller. When it is returning a positive value, then we can say it is la. And then when it is returning a zero, it seems like equal. If you don't want to provide a comparison logic in a class itself of the object which you are putting in a tree set, or rather in another case where we can say like I want to sort my objects on the different cases in different scenario. So in that case, only one compare to method is just not, we cannot depend on a one single method. So in that scenario, we can write our own comparator which compares two distinct objects based on certain different criteria. So you can have multiple comparators which are comparing two objects on the different scenario, and then we can pass those comparators to the tree set while creating its instance by calling it, by passing the comparator instance to the constructor. Iterator is one more thing which we can talk about, like it is similar to the enumeration but not exactly similar. It has some more features. Iterator is an object which helps you to iterate over a collection. So it knows the internal structure, that how that specific collection has been structured and how it can access element from another element and all those things. So iterator provides you a way to iterate over element. Even it also provides you a way to remove an element which you have just iterated from the underlying collection as well. There is one more iterator which is given by the specifically for the list, is what a list iterator. That list iterator travels to the list in both the direction, whereas iterator just travels on the forward direction. It can go to the backward as well. and with the functionality of removing element from the underlying collection, list iterator also gives a facility to update the element in the underlying collection. Then two more classes has been given by the collection framework, which is collections and arrays. So we have a collection without S as an interface, and we have a collections with S as a class. So this collections class contains mainly a static method which are used to operate on a collections, and which mainly returns you the different collections. So you can convert from one type of a collection to another, as well as you can get the synchronized collection from that. So what was the difference and why these classes has been introduced in the collection framework 1.2? So the difference is between classes of collection framework of Java 1.2 and the legacy classes is vector, which was given in Java basic Java as basic vector, and array list is what? Array list is unsynchronized, non-synchronized, whereas the vector is a synchronized one. Means when you are when one thread is operating on a vector, either for inserting or removing or iterating at the same point of time, other thread cannot work on that. Whereas array list is not a synchronized one, so multiple threads can access it on it simultaneously. But though if you require like a synchronized kind of a collection, then collections has a method to which returns you the synchronized form of a color, your array list. So those kind of methods are added in a collections class. Similar is what with hash table and hash map. Hash table is a synchronized mapping collection, whereas hash table is an unsynchronized one. Arrays class provide you different method which you can use for manipulating arrays, such as sorting, searching, and it also provides you the views as a list for those arrays. Like if you want to get the arrays in form of an array list or so you can use the arrays class and its static methods. Then the next addition was in Java 1.4. In 1.4, identity hash map, linked hash map, and linked hash set has been added. Identity hash map has been added where the implementation is different from hash map in a manner like hash map talks about when you ask for any key, that this key is present in a hash map or not. It gives a call to the equals method on that key object. So if you have overridden the equals method properly, so you can identify that though there are two distinct objects, one which is stored as a key in a hash map and one which you are passing to get it as to get the value, though it's a two distinct object, but these two objects are equal. Based on the equals comparison, it will give you. It doesn't happen the same way in identity hash map. Identity hash map just checks on the reference equality in place of the object equality when comparing the key. Then why do we have this kind of a hash map in framework? So these kind of a hash map mainly use when you are like working with the objects, and you might have multiple objects with the same content, but though like each objects are different. These are, we can talk about like when I am passing an XML document where two XML tags contain the same value, but still like I want to process or I want to put both the objects in a hash map as a key, and I want to process it one by one. So in that case I can talk about or I can work with the identity hash map where I can put both the objects as a key, where like objects has a different references, so I can put it over there. I cannot put those both the objects having the same content if I have overridden equals method, and then it is a normal hash map, because it doesn't allow you to put duplicate keys in a hash map. when we were talking about any collection which has word hash is what it gets stored internally in hashing algorithm, like it has certain buckets where it will put the elements, and those buckets are identified based on certain hash value. So again, hash value, who will provide a hash value to collection? None other than the object itself. So we have a hash code method given by the java.lang.object class and available in each and every object. So collection just gives a call to hash code method on each and every object, which gives a hash code, and based on that the bucket is allocated to that specific object. That's why when you are putting the objects in a set, or any rather we can say hash set or hash map, we never know that where that object is going to be stored, and when it is getting iterated, it just get iterated. Like after each, it just goes to one bucket, identifies the all objects is stored in that bucket, and then puts that in a iteration kind of a thing. So in case of a hash set or hash map, we never get, or we cannot guarantee that we'll get the elements in the insertion order when we are iterating it. But if that is what your requirement, that I want to get the objects in the way like I have inserted it, then we can talk about linked hash map for the key. It just put the keys in insertion or entry of key and value in the insertion manner. It will give you when you will iterate through the iterator, and the same with the linked hash set. It will give you the element in the same order in which you have inserted. When we are talking about linked hash map and hash set, and when it is preserving your order in which you have inserted, obviously it is adding the performance overhead as well. So in which scenario you will go for using it? Let's say if one method is getting a parameter of a hash map and with certain value, 3-4 different value, and that method's job is what, like work on these 4 different value and update it and then send it back to the client with the different results of those 4 different values. Or we can say like a 4 task has been given in a hash map, and then you are supposed to return a result of these 4 tasks. So in this scenario, when user of that specific method is sending a task in form of a hash map for execution, then obviously that user who have called a method will like to see the outcome also in the similar order. And in this scenario, we can go and work with a linked hash map so that we can return in the specific order in which we are inserting. Java 5 has given a drastic change to collection framework. Java 5 has introduced so many new concepts, and rather not only for the collection framework, it has given so many new things to the Java as a language itself. So Java, we'll just talk about the additions which happens to the collection framework in Java 5. In Java 5, we get a new thing in Java as a language level component is what an enum. We can define an enum just like in a C or C++ kind of enum in a Java. So they have given us a Java enum map and enum set, where we can put in enum map. It is what like you can put a enum as a key, and value you can put as object, where like in enum set you can put a enum as element in a set. So it just like a set and map, like sorted set and sorted map, which supporting for the enum as a key or the element values. One more thing which was added in Java 5 was queue. So queue represents a collection which is designed for holding elements prior to processing. So it is just like the same concept of a queue from a data structure, where it works on the FIFO, like first in first out mechanism, and the firstly entered value will be returned. So it has a head and tail. Priority queue. Priority queue is what something different. It's a queue, but we cannot say that it will work on FIFO mechanism only, where like you can provide a comparator to the queue object which will say that what is the priority of this object, and based on the priority that object will be given when you are pulling the object from a queue. So it might possible that the order in which it has been inserted, it's not at all maintained when we are working with a priority queue, and when it gets similar priority objects, in that case arbitrarily it selects one and then gives when you are pulling it. So priority queues are queue, but still it not works on the FIFO mechanism if you are giving your own comparator for a priority. If you are not giving, then it works with the natural order. And one more thing which was added in Java 5.0 was generics. So generics was adds compile time type safety to the collection frameworks and eliminates the need to cast. Earlier, like in Java 1.2, when the collection framework was given, or rather the classes prior to that, like vector and hash table, was having a methods like add, which accepts object, and get, which returns object. So each time when you are passing any object, let's say like employee class object, you don't need to typecast while putting it in add method, but while getting from the get method, or let's say any other method which returning you the element of iterator next method also. So in that scenario, you were supposed to be forced to typecast that into your own employee type so that you can use it as an employee. So that kind of binding now has been removed from a generics, because now you can define a collection with a specific type at the time of creating the instance itself. So when you are calling a get method on that instance, you are very sure that I am going to get this specific type of object itself, so you don't need to typecast. Even it doesn't allow you to add the objects of any other type to that collection, so that you can guarantee that if I am creating a collection, or let's say list of a string, no one can add integer to that list, or no one can let's say all the times when I am calling a get method on that collection, I will be getting the string itself, string type only. So it is something similar to template concept in C++. Some more thing which was been added and which has impacted collection was in Java 5.0 is enhanced for loop. When we wanted to iterate over a collection earlier to Java 5.0, we were supposed to use like get a iterator and then put like a while loop till the iterator next doesn't return you null, and then or put like a loop for if it is a list, then I is equal to 0, I is less than, let's say list object dot size and I plus plus kind of a thing. So these things can be eliminated with the help of enhanced for loop, where it just gives like a for each, and you can pass the collection and all those things. So you don't need to put the specific condition and all those things, and that loop will go on till it has the elements to iterate in a collection. The interesting part which was been introduced in Java 5.0 was autoboxing and unboxing. As we all know that collections are based on the object type, means it takes the object type to stored in it, or like add method expects object and get method returns object. And what's about the primitive values? So in that case, the answer was only like wrap it using a wrapper objects and then put those wrapper objects into the collection. Again, whenever you are getting that, you need to get you will be getting an or wrapper class object, and then you need to get the primitive value, and then you need to work on that. So that is what been cleared with the help of autoboxing and unboxing. Autoboxing talks about like converting primitive type value directly to the wrapper object. So you can now pass directly a primitive value to the add method of your collection, and with the help of autoboxing it will be directly converted to the its associated wrapper class object. And when you are getting a get, you can have the primitive data type variable at the left hand side of your assignment operator, and the value will be directly getting unboxed, or we can say converted to the primitive type, and will be set to the variable. This was the addition of specifically language components, whereas like in collection framework in Java 5.0, as I said, like it was a drastic change. They have added one more package with name concurrent. So java.util.concurrent package has been introduced in Java 5.0 with some additional type of a collection. So out of which we'll just talk about one by one. Blocking queue. So it is the interface which extends queue interface and which operate just like a queue, but over here it blocks for putting the values in a queue if it is not empty. So that queue to become non-empty when retrieving an element, and it keeps on waiting. So it is like a blocking call when you are calling like pull an element from a queue, and if the element is not available in a queue, your call will be like a blocking call. Unless and until you get some element from a queue, your call will not get completed. So this is what a blocking queue. Linked blocking queue is what an implementation given for the blocking queue, which is what just we can say a blocking queue which is backed by the linked list. Priority blocking queue. So it is a priority queue which is a blocking queue. So an unbounded blocking priority queue backed by a heap memory. Synchronous queue. It is just a simple queue which is not at all actually a queue. Synchronous queue has just like a value which there is only one value which you can talk about, like is given, like you are adding a value and some another thread is reading a value from that. So when we are talking about all these different classes and interfaces added in a concurrent package, and even the name suggests concurrent, so all these type of collections are added specifically for to execute in a multi-threaded environment, or we can say to support a concurrency in Java. As we have already discussed that the interfaces, the classes or collection implementation given in Java 1.2 like array list, linked list and all those things are not synchronized. So they are coded to throw concurrent exception or different kind of exception when two threads are accessing the same collections or modifying the same collections at same point of a time. Whereas these concurrent package collections like a blocking queue or synchronous queue and array blocking queue, all those things doesn't throw you that kind of exceptions, and it can be used in a multiple threaded model. Blocking queue is what we can say a better example where we can talk about the scenario. Let's say if I have multiple threads which are putting some value, and there are multiple threads which are reading those values from a collection and then working on it. So kind of a messaging structure. So the queue can be worked as a destination for a thread who are putting values for the another thread which is becoming as an input value. So each thread will put a value to that, and another thread will pull a value from the blocking queue. So unless and until it gets a value, it will not be in return. That call, the call to pulling the value will not be returned, so that it will assure that it will get a value all the times. Delay queue, it is a time-based scheduling queue backed by a heap, where each and every element will be available to pull unless and only after completing its the given delay, which is given in a nanoseconds. So we can schedule that this element will be available after this much of a nanosecond for a pulling purpose in a delay queue. So delay queue is something like a priority queue, where like a priority defines that which object will be pulled in next cycle, and where in a delay queue the delay time, which if the object's delay time is 0 or less than 0, only that object will be pulled from a queue in case of a delay queue. Concurrent map, it is concurrent map interface extends map interface with atomic put, if, absent, and remove and replace methods, which is added one. But mainly we can say it is the map which can work with multi-threaded environment, and we can have the multiple threads working on it. Concurrent hash map, highly concurrent, high performance concurrent map implemented backed by the hash table, which is an implementation of a concurrent map. Concurrent linked queue is what a queue implemented has a linked list and it is optimized for the concurrency. So we can say an unbounded thread safe FIFO queue backed by a linked node. Copy on write array list and copy on write array set. I will talk about this just after giving an explanation that why we have these interfaces in classes as a separate package. As we have discussed in a collections class, we have a certain method which returns you the synchronized form of the given collection. Like there are methods synchronized list. By passing a normal list object, you were able to get a synchronized form of a list, so that we can work with the multiple we can work with that object in a multi-threaded environment. Then why we required a separate package itself with a different implementation for the multi-threaded environment? So the difference in synchronized map or synchronized list set and the concurrent map and concurrent list is what? In the concurrent map or concurrent list or concurrent queue, we can talk about where the read call is not a blocking call. So multiple objects can read simultaneously, as well as multiple threads can also write on the same object simultaneously. So over here the lock is obtained on very fine level. It is not obtained on the complete object level, which was the case with the synchronized map and all those things. So in case of a synchronized map, when one thread is updating a map, another thread has to be put on a hold so that it will get the lock on that object which is released by the earlier thread, and then only it can do. But the same thing is not with the concurrent package implementation, where the lock is been acquired on the very fine level. So two or more than two threads can work simultaneously with the concurrent map or concurrent list kind of a thing. Okay. Now we'll talk about copy on write array list and copy on write array set. You can talk about this as a list given for the concurrency purpose, or a list implementation backed by array, and which is specifically designed for the multi-threaded environment. All mutative operations such as add, set, and remove and all those things are implemented by making a new copy of the array. So we can say like when you are adding any element to a copy on write array list or copy on write array set, the difference is only of the difference which we have in the list and set. So I will just explain it in the same manner. So in both the cases, it just creates a separate copy. So the iterator which has been you have get it before updation will work on its own separate copy. So you won't be getting concurrent exception anymore. In Java 6, we have a DQ, is what double-ended queue, or we can say doubly, where you can get the values from both the ends and where you can push the values from both the ends. Navigable set, where you can navigate from any way, whereas and even you can search for the closest matches based on the values. Navigable map, that is similar to the navigable set, where you can search for the entries based on the given values for the key and all those things. So you have over here like a ceiling floor kind of a method which gives you the nearest entry for that specific value which you are passing. Array DQ is an implementation for the double-ended queue in form of an array. Then some more classes has been added in a concurrent package which are blocking DQ, like a blocking implementation of a double-ended queue, concurrent navigable map. Concurrent navigable map is what concurrent map that is also a navigable map, we can say. Concurrent skip list set, like a concurrent scalable skip list implementation of a navigable set. Linked blocking queue, the same way the concurrent skip list map. Linked blocking queue is what a concurrent scalable of optionally bounded FIFO blocking DQ backed by the link node. So we have already talked about linked list, we have talked about blocking queue. So it is what the blocking queue implemented via linked list. In Java 7, two things has been added in a concurrent package was a transfer queue and the implementation of that as a link transfer queue. So it is a refinement of a blocking queue where a producer can wait for a consumer to receive an element. So here your add call is also a blocking call if you want. Otherwise you can put the elements in a queue though it is not been consumed by calling a put method. Now this was just an introduction about different classes and interfaces added and on time by time. So now we'll just talk about different things and the best practices. Why we should upgrade from the legacy to the collection classes. Let's say like earlier time when we haven't had the collection framework, so we have written a code with vector and hash table and all those things. So should we upgrade it? My answer is yes. And why should we go for that? So we should go for that because our application will become more flexible if our code is with interfaces, not with the implementation. As vector doesn't have at that point of a time any interface, so we have like reference is also created of a type vector and object is also created of a type vector. Instead of that, now we can convert it that like reference is created of a type list and the object is created of a type vector. Vector is also rectified to implement a list interface. So nowadays vector is a type of list only. Then we get a flexibility to change the collection implementation easily based on a new requirements or amendments in a collection framework. As a, let's say like earlier way I was using with array list and now I have a linked list. So if I want to switch from array list to linked list, I just need to go at a place where I have created an instance of array list and I will just create a instance of a linked list, but I don't need to change the reference or the method call and all those things because we have defined a reference of type list itself. So that is what we talked about, we discussed in the point 1. Then we can get a performance by using unsynchronized collection implementation wherever possible, because legacy classes, as we discussed, all are synchronized and synchronization comes with its own cost. Let's talk with some best practices which we should apply when we are working with the collections, so that it will reduce the runtime errors as well as it will increase your performance. Do remember to override equals method in for all the classes which objects you are going to put in any type of a collection, either it is a set, list or map. And make sure that you are overriding hash code method as well for those classes which instance you are going to put in a hashed type of a collection, either in a hash set or hash map or something like that. There is a contract between equals and hash code method which is very nicely given on Java Talks. So I hope we all are aware of that, but I will just strongly say if we are not, we should go through that and we should see that we are adhering that specific contract and putting it in our code. Do not override hash code to return either unique value for each and every object, which normally a Java implementation, basic object class implementation is doing, and either return a very constant value for all the objects. Hash code is used to identify a bucket where that object will get stored. So hash code should be generated in such a way so that all the objects which we are storing in a hashing type of a collection will be in a balanced way in all the buckets, so that it will not happen that it is just going on increasing the number of buckets and in each bucket we have a single object, or neither it should happen that in a single bucket all objects we are putting. So if you are giving a constant value, like say in a hash code method returns number 5, so it will say like the bucket allocated for number 5 will be used for all the objects of that specific class. So it doesn't provide you a better performance when you are going to get or any check operations over a collection, because when you are getting the values from that type of a collection, it has to go through the linear search from that specific bucket, or neither having a huge number of buckets will degrade a performance when you are iterating over that specific collection. So when you are overriding a hash code method, make sure that you are giving a proper implementation for a hash code method so that your objects in that specific collection will be in a balanced way. Then always keep your equals and hash code method in sync. That the same thing which I just said is what maintain the contract between hash code and equals method, where the contract says like a two equal objects according to the equal method should always return the same hash code. When the requirement is something like you wanted to return a sorted kind of a collection, so don't create the collection like a tree set kind of object at first and keep adding the elements to that tree set. It will ask tree set to each and every insertion to reorder the existing objects according to the given comparison criteria. Instead of that, you can use a hash set object and add all the instances to the hash set object, and then finally create a tree set from that like a sorted set and then return it, so that the reordering or rearranging of all elements according to the comparison criteria will happen only once, and in this way we can gain some certain performance. Then for hashing kind of a thing or any collection which is like a growable, we have two values like initial capacity as well as the load factor. Initial capacity talks about that what should be the initial set of how many elements it can have with the initial memory allocation. So that is what initial capacity, and the load factor is talks about after filling how much of that initial memory it should go on the growing phase. So the initial capacity should not be very small, so that it will keep on creating a new array. If it is, let's say, array list, so it is backed as array list is backed by array. So in case of like when we are adding elements to array list, and when it's come to the load factor of its initial capacity, let's say initial capacity is 10 and load factor is 7, so when you will fill 70, so 0.70, that is what like in value. So when it will come, when it reaches to the element 7, and when you are adding the 8th element, it will create a new array. It will copy all the elements over there, and then it will put over there. So the similar way it will go on the existing size with the point with multiplied by the load factor. So make sure that you are giving appropriate initial capacity and load factor for the collection instance, so that it will not going to create the underlying data structure like array each time again and again, and then copying the things, so as you can gain the performance over there as well. While using collections as an attribute type in your class, like many a times we do, like there is a class and containing a list type of attributes, let's say like students and having a marks. So you have marks is what type of a list. So never expose that directly by making a public attribute, or by providing a getter setter methods like get marks or set marks. Rather that you can provide getter setter methods for the element of collection. If you are providing getter setter methods, or if you are exposing that collection itself by using a getter and setter, then it might possible that your collection itself can directly be changed by the calling function. Use array list for one-time adding and many-time iteration scenario. Where like array list is what backed by array, so iteration or fetching of a data is least. It takes least time in the arrays, because it is like values can be accessed with the help of indexes directly. So when we have like one-time adding and multiple time fetching kind of a scenario, then we should go with the array list instead of a linked list. And when we have multiple time adding, removing and all those things and less iterations, then we can go with a linked list, because for iterating over a linked list, it's a linear way and it has to go with from one node to another, so it takes more time compared to array list. But for adding element, it doesn't need to swap the all the elements and all those things just way the way like we need to do it with arrays. So adding or removing the elements in between is what little bit easy with the help of linked list, but still like iterating over a linked list is what costly affair. Array list provides high performance for positional access, where linked list provides high performance for additional deletion in between or compared to each other. Create an array list instance with appropriate capacity to avoid creating and copying elements to new internal array while growing. It's just same like which we discussed earlier, that initial capacity and load factor should be given with the proper way. Getting nth element in linked list requires sequential scan from start to end, and this is very slow. So as I said, like if you want arbitrarily you want to fetch the values, then it's better to go with the array list, because we are accessing arrays with the help of indexes. So nth element of that array can be given in the same time, the way like you are getting a first or second last element. It is good programming practice to use the highest level abstraction for the object specification wherever possible. In a simple meaning, it is said that like your all references should be of a type of interfaces defined in the collection framework, and then object should be of obviously a class type. So the interface, the references should be either of a type list, map, or set, whereas the instances of that specific implementation you will create. So each time give the appropriate abstraction, so that it will give you the highest level of abstraction as well as give you the free hand to change your implementation anytime. Array DQ class is likely to be faster than stack when used as a stack, and faster than a linked list when used as a queue. So it's better now that we can use an array DQ, which is added in a 6 if we want to work with a stack or a queue kind of a mechanism. The thing which has been added in collection like tricks, so there is no at all a performance impact because of the generics, as it is just a compile time trick for providing a type safety. So when it is generating a byte code, there is no type information is generated in a byte code. You will get a byte code just same as it was getting generated before generics. Generics are not covariant. It means like we can talk about let's say the example which is given in a slide as like a number is a super type of an integer. So I can create a reference of a number and assign an object of an integer. Even the same thing is valid with the arrays. So like a number array is a super type of an integer array. So I can create a reference of type number array and I can pass the object of an integer array to that one, but it doesn't work with the generics. Just like as in a list of integer cannot be passed to a method which is expecting list of a number. So we need to make sure that it will give you a compile time error, and it gives that because it might possible that if you are passing a list of integer to a method where it is being treated as a list of number, so float is also kind of a number and you can add that to the integer list, which you should not. So to avoid that one, collections with the generics is not been like you cannot assign just like as an arrays. In case of performance, this is what some values when I executed code on my machine. Like I work with the 50,000 objects and different type of operation I did with the different kind of implementations. So like array list when it was initialized, not initialized, and when it is initialized, so there was considerable time difference when I was adding the objects at end, because it wasn't required to copy and create a new arrays many times, because I have created that array list with specific initialization values. Similar with a vector, the time difference was something more compared to the array list because of the synchronization. And with a linked list, it was constant because of like linked list contains both the ends, like head and last. Adding in middle was again the similar for the array list with without initialization and with initialization, with not much difference. But with a linked list, it was little bit more because of the traversing issues. Like for adding at a specific location, that pointer has to be traversed from the head to that specific location, and the traversing over a linked list is always a time-consuming process compared to the arrays. And adding objects at first, where the linked list was a winner, because it doesn't need to swap any other objects in case the thing which requires in case of arrays, like when you are adding an element in between of let's say like at first place of array, then each and every element has to be swapped from its place to the next place, which doesn't require in the case of a linked list. Similar way, like removing object from an end, which like initialization doesn't make any impact on that. So like removing an object from an end where like linked list was more having performed well, and removing objects from a middle, in that case linked list was again having a performance overhead because of the iteration, or we can say fetching each and every element and all those things. So similarly, like we have other values also, like accessing the objects. Accessing to get the values, its array is always a better way, better type of a collection to fetch the values from a collection and all. So this is what from me. Now I hope as it was not the full length training, so I just tried to cover the different additions happen in collection framework, and then the different things which like to do and not to do with collection frameworks and all those things. Now you can ask me questions if you have.
The questions are already shared with you. Can you please see them in the questions pane?
Okay. The question which is asked by Mr. Ravi Soni, why Java vector class is considered obsolete or unofficially deprecated, or why should I always use an array list over a vector? See, because as vector is not that good for performance compared to the classes which is given in a concurrent package in Java 6.0, as well as array list is what the basic implementation of vector of a list, and whereas vector has its own methods which was been available in that prior to the collection framework, like getting enumerator and elements and next element and that kind of a thing. So to avoid use of enumeration and all those things, it is been considered that unofficial, it is deprecated, and we should go and work with array list, which supports to all the methods from 1.2 to 7.0. Okay. The Akshay has asked a question like, give me example when we can use weak hash map. Weak hash map can be used when you are working with a trees or graphs kind of a application where you are supposed to reach to the each node and process it and all those things, and you wanted to keep the unprocessed nodes in certain collection so that you can go back to that collection to get the unprocessed nodes and all those things. The way like I have given an example of XML parse XML where it is the XML is converted in form of a nodes. So before processing, I wanted to reach to the leaf node and then process it and then come back to the parent node kind of a thing. In that scenario, it might possible that my two nodes containing the same content, but just because it is in a different hierarchy or it is belongs to the different parents, it has a different meaning. So I cannot keep like these two objects which are equal based on the content or might be on my equals method. I cannot keep two objects which are equal according to the equals method in a hash map. In that case, I can go with the weak hash map where I just want that after completing my processing, it should get removed from the hash map itself. So as I lose the reference to that specific instance or that specific entry, it will get removed from the hash map. That is where we can use a weak hash map. Okay. The same. He has just asked one more question, which talks about how the buckets work in a hash map and hash set. See, bucket is nothing else. We can say it is kind of a container which will contain your objects or elements of your collection. So in case of a hash map, the buckets are identified based on the hash value of your key, and in case of a set, it is identified based on the hash value of your element. So when you are putting an element or an entry in a hash map or a hash set, the hash value is calculated by calling hash code method either on a key or the element, and then the bucket is identified where that object will be stored. If it might possible that in same bucket we have multiple objects. So when we are searching any objects via calling a contents method, it just identified a bucket first, like where to search, and in that bucket it just goes on the linear searching. So to get the object appropriately, it is very much important that we should, the collection should reach to the appropriate bucket, and then only should start with the linear searching and the given objects in that specific bucket. And for that reason, the hash code method has to be override appropriately. Okay. Can we set, another question is what, can we set priority for two or more objects sequentially to retrieve from priority queue? Okay, though the question is a little bit unclear to me, I will just give the explanation about priority queue. Is what priority queue is associated with comparator, the way like your tree set or sorted set is associated with a comparator. In case of a sorted set, like comparator gives the location of that specific element for the sorting purpose. In similar way, in a priority queue, that comparator gives a location of that specific element based on its priority. So when you are pulling the element or picking up the element from a queue, you will get the element which is having a highest priority according to the comparator. So the object is not setting its priority, whereas like a comparator who is setting the priority for that specific object, and you can get the object from a priority queue which has the highest priority. If you are not providing a comparator, then priority queue will work just same as the normal queue. Okay. In real time, is linked list data structure or arrays are used? Yeah. Arrays are used rather not only in real time, even the basic implementation of the collection frameworks is depend on array. As we have seen in the last slide, that array provides us a better performance when we have we wanted to search with the or fetch the values, and when we have like a fixed set of elements which we know that okay, only these many elements we have and we wanted to access it, then we can work with the arrays. And some applications or like some developers are still in favor of using arrays, but obviously it has to be it has its own constraints with it. Okay. Venkatesh has asked a question, why we use generics in collections? Without generics also we can do the operations. Can you tell me the reasons? We are using a generics in the collection just to avoid the additional code which we were supposed to write for typecasting all the times when we are getting the values, as well as it provides the type safety at compile time. As I said, like it doesn't add any kind of overhead, performance overhead at runtime. So it is a better way of writing a code where like when you have defined a method which accepts that a list of type string and you have written a code, let's say, which is working on that specific element's string type, considering that the element which you will be getting in a list of a type string, so it should not get spoiled because someone is sending an integer instead of a string to that specific list. So it is what we can say safer coding with minimal code. That is what use of a generics. Okay. This is in relation with the previous question of a priority queue. Akshay has added some more clarification what he wanted to say, that he just wanted to say that can he set priority to retrieve objects in a particular sequence, like first want to retrieve A element and then retrieve H element. See over here, when you want to retrieve a specific element, obviously the collection is working based on your comparator only. So if comparator says that this element should be given first because of its priority, then you will be getting that element. So here elements identity to get the elements from a priority queue is its own priority given by the comparator itself. So you will be getting the element which has the highest priority according to the logic which you have given in your comparator. There is one question from Durga Prasad. He says like map is not comes under util package, then still we use as collections. Can you tell me why we use the map as collections and what is the benefit compared to list and set? Uh, the first statement is not completely correct. Map comes under the util package. So we say like java.util.map. Map is an interface which says that you can store the values in form of a key and value pair. Many a times we need that value has to be stored with a key, and we never know that what the value will be, but we know that this value will be accessed with a specific key. It could be like when one method is passing multiple values to the another method, and this is what like might be a subset of the contracted specific set of values. Then in that case, we can use a map kind of a thing where the key are common based on the understanding of both the methods, but the value which you are putting might be vary on time to time basis. So the method which is calling another method can set certain entries in that map with a specific keys, and the called method can get those values from that map by calling by getting those with the help of the predefined keys. And the same thing is not available with a list and set. In list and set, we don't have any meta information to fetch the elements, where like map provides you the meta information like a key, which can be a string or number, which you can pass and get the object. So that is what the benefit over list and set. But as an implementation, map internally implemented as a set only, but it's a set of an entry, and entry means a key and value. Okay. There is one question from Venkat. Can you explain about difference between compare and comparator? I think the question is supposed to be comparable and comparator. Comparable is an interface which is implemented by the class, which objects we want to compare with each other, and that class implements a comparable interface and override a method compare to, where we just get one object of similar comparable type, and we can compare the incoming parameter like incoming object with the object itself on which the compare to method is being called. Whereas comparator is completely separated from that class and has the compare method which accepts two objects of type comparable, and where you can pass any two objects to compare that one. It helps you, like comparator helps you to provide different comparison logic, or we can say multiple comparison logic at given time, and it also been used with the classes where you are not able to change its code and then overwrite or to put your own implementation to the compare to method. Though there are some questions are still remaining, but because of a time constraint, I cannot continue with all other one.
We can answer these questions offline also. I think now we can conclude the session now.
Yeah. Thanks all.
Thanks, Mr. Bhushan, for your informative session on effective use of collection framework. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgeek.com by tomorrow. The next session in the Advanced Java webinar series is happening on 6th January at 3 p.m. Topic is Java 7 Productive Language Enhancements for Developers. Speaker would be Hemant Kumar Dugar, training consultant at Login to Java. So see you all on 6th January at 3 p.m. Have a nice day and a very happy new year. Thank you.